I just identified that we are having two forms of the equations. One is equation of the line in parametric form, where we are using this definition that P1P is equal to V times T times V. So we get here this is x equal to x1 plus a1t, y equal to y1 plus a2t, and z equal to z1 plus a3t, where t is any real number. So the second is the equation of line in symmetric form. There we use the definition that a1 over b1 over a1 is equal to b2 over a2 is equal to b3 over a3 equal to t. So our p1p, we take this as b and this we take as a. So we get here x minus x1 over a1 is equal to y minus y1 over a2 is equal to z minus z1 over a3 is equal to t, some constant. T is any real number. So this here two form of the equations. One is the equation of the line in, we say in parametric form. So we can write like this one, and here equation of the line in symmetric form. This equation of line is like this one. So here we want to find the equation of the line parallel to the passing through this point and parallel to this vector. Solution of this one, we write here the parametric form first. Parametric form of equation of line. We are having here x is equal to x1. This is my x1, y1, z1. 4. a1 is 1 plus t. Y is equal to y1 is 3 plus 2t. And z equal to z1. z1 is 2. And here is the a3 plus 3t, where t is any real number. Then here number 2, we write here symmetric form of the equation of line. Equation of line. We can find the value of t, we can say it here. This x minus x1 over a, y minus y1 over b, a2, and z minus z1 over a3. Or we use that formula. So we get here x minus 4 over a1 is 1. Y minus 3 over 2, z minus 2 over 3 equal to t. We can derive from this one the value of t and substitute like this one. The same thing as we did it here. So we can use the point. So given me two things, I need a point and I need a vector. You can write the equation of the line. This is the parametric form and this is the symmetric form. Another example, we want to find the equation of the line passing through the points P1, P2. So it's my line. This point is P1 and point is P2. What I need to write the equation of the line, we need a point and a vector. So we find the vector P1, P2, I take it out. This is my vector P1, P2. I say it's my vector V. Vector V1 is P1 and P2. So here we can take any point. We can take the point P1 and we have the vector. So we can write equation of the line. So here we need to find, because the points are given, the vector is not given. The line is parallel to the parallel to the line passing through these 2 points. So we will get here, passing through these 2 points, we get this vector, and we just take this vector out and we write P1, P2. So I find here a vector. Vector was not given. That vector V is equal to P1, P2, and we get here this equal to P2 minus 7 minus 3, we get here 10. We get 11 minus 1 is equal to 10. And then here minus 8 plus 1 is minus 7. This is my vector. No, this is my vector. No, we say let, because we can take any one. We let the point be. We can take point P1 or we take point P2. Point B P1, and coordinates of P1 are minus 3, 1 and minus 1. So we can write equation of the line. When we are not given, not asked that we want to find the equation of line in parametric form, we write in the equation in the form of the, not in the symmetric form, we write in the parametric form. We get here x equal to x1, x1 is minus 3, plus a1t, a1 is 10, 10t, y equal to y1, y1 is 1, plus a2t, a2 is 10, so we get here 10, 10t, 10t, and then z is equal to z1, z1 is minus 1, plus a2t, a3t, a3 is minus 7, so we get here minus 7t, where t is any real number. So even you can take here the other point P2, and we can write here the equation of the line. That's here is the point is P2 instead of P1, and we can have the vector we are having here. So as a note, we can take note, let point be P2, and we are having the coordinates of point P2 is 7, 11, and minus 8. And our vector is vector v, and vector v is our vector passing through point P1, P2 is 10, and we have here 10, and get here minus 7. So I can write the equation of the line. So line, equation of line, parametric form is x equal to x1, 7 plus 10t, y is equal to 11 plus 10t, and z is equal to minus 8 minus 7t, where t is any real number. You can see it here that we can have many equations of the lines, because for the point, when the point is changing, then the line is changing. When we change here the point x1, y1, z1, then equation line is, but we remember it that v is constant. That's not changing. This remains 10, 10, and minus 7. 10, 10, and minus 7, the vector is not changing. Point can be any point on the line. Here we can have any point x1, y1, z1. But this a1, a2 is fixed, that's not going to change. So this is how we can find the equation of the line passing through 2 points. Before giving the next example, I just want to explain you, when given the equation of the line, I can find the vector parallel to the line. What is the vector parallel to the line? This is my coefficient of t, a1, a2, e3. So example here we have the vector. I want to find vector to parallel to the line, parallel to line. This is a very simple one. That's the coefficient of t. So vector v is equal to a1 is minus 1, a2 is 4, and a3 is minus 2. So this is one. If I want to find the point on the line, so the point on the line, number one, very simple one. We take t equal to 0. We get x1, y1, z1. We take t equal to 0, the point, say point P1 is 2, 3, and minus 5. I can find points on the line. We take point P2, and here I take t equal to 1. Here I take t equal to 0. When I take t equal to 1, I get here 1. T equal to 1, I get here 7. T equal to 1, I get here minus 7. So this is another point. I take another point on the line, t equal to minus 1. Then point P3 is equal to t equal to minus 1. I get here 3. T equal to minus 1. I get here minus 1. T equal to minus 1. I get minus 3, and so on. Because we can have infinite number of points on the line, we can get it. So important part of my discussion is that given a line, you can find the vector parallel to the line. So this is a vector parallel to the line, and we can get here the points on the line. Simple case is when we take t equal to 0, we can get here the point that is x1, y1, z1. In this example, we want to find the parametric equation of the line passing through the point P and parallel to this line to make the graph. So we have this line L1 given by these equations. And we have the point. This is point P, minus 6, 4, and minus 3. We want to find the equation of line L. So we need two things again. We need a point and we need the vector. From where we get the vector? A vector will parallel to the line. Vector will parallel to the line. And we can find a vector we need that is parallel to line L1. We get here this vector V. The vector V will be having the components. This my A is minus 3. My A2 is 1. My A3 is 9. So it's my vector V. So I can find now I have the point on the line and we have the vector. The point on the line is point P, and the point P is having the coordinates 6, 4, and minus 3. So again we get a point, and we get a vector. So this is my point, it's vector. I can write my equation of the line. So I have the point x1. Here we have the point P, is the coordinates are x1, y1 and z1. So we can have the point and the vector we can write here now. My x is equal to x1, this minus 6 plus a1t minus 3t. Y is equal to y1, y1 is 4 plus a2t is t, and z equal to z1, z1 is minus 3 and plus 9t, t is any real number. So is the equation of the line passing through the point this one and parallel to this line. This is my equation of line L. Equation of line L, because we have two lines, so we distinguish this one line by L1 and this by line L. The line L is this equation, that's value of x, y and z.